If you remember from earlier in the book, absolute value is the distance a number is from 0 on the number line. It can never be negative. So when you're solving situations involving absolute value, what you want to do is isolate the absolute value, get it by itself, split it off into two parts, positive and negative, and solve. So the reason that you're splitting off into positive and negative is this first example right here. So this reads that the absolute value of x equals 4. So this is asking, give me a number for x such that the distance this number is from 0 on the number line is 4. Well, there's two answers. I'm going to branch it off. It can be 4 and negative 4. That's why we're going to branch it off. So this has two solutions. Same thing here. This is asking what's the distance this number is from 0 on the number line. But you cannot have a negative distance. So you can't set, so this one has no solution. So whenever you're solving and you have absolute value, once you've isolated it equals a negative number, it's no solution. There's no number for y such that when you take the absolute value of it, you get a distance of negative 5. So number 3, the absolute value is already isolated, so I'm going to write it up into 2. So I got x minus 5 equals positive 12, because this could be positive 12, but this also could be negative 12. So then I'm going to solve for x, and I get x equals negative 7, or x could be 17. Two completely different numbers. Could both work when you plug them in. Number 4, I have to isolate the absolute value first. I treat this like a parentheses in that, not that I can distribute, you can never distribute into an absolute value, but I can divide both sides by 2. So I get x plus 4 equals 4, the absolute value of it. Now once you get the absolute value by itself, you can now branch off. So I could have x plus 4 could equal positive 4, and x plus 4 could equal negative 4. And when I solve, I get x equals 0, or x could be negative 8. Okay, number 6, I have to get the absolute value by itself. So I'm going to subtract 6 from each side. So I'll get negative x minus 2 equals 6. Now just because there's a negative doesn't mean it's no solution. It's got to be the absolute value equaling a negative number. So I can still branch off and do opposite x minus 2 equals positive 6, and opposite x minus 2 equals negative 6. So I'm going to solve for x in each one, add 2, opposite x equals 8, so x has to equal negative 8 is one solution, add 2, opposite x equals negative 4, x equals 4 is another solution. Okay, number 6. Solve for x, you want to get the absolute value by itself. So first, remember you can't distribute here. First you need to get rid of the 6. Kind of treat this like a variable where you would subtract and then divide. So I'm going to subtract 6. So I get negative 3 times the absolute value of x plus 2 equals 12. Now a common mistake is for people to add, but this is being multiplied, so you have to divide by negative 3 from both sides. So you're going to get the absolute value of x plus 2 equals negative 4. So at this point you would normally split off and do x plus 2 equals negative 4 and x plus 2 equals positive 4. But remember that you have a distance equals a negative number. You can't do that, so this is actually no solution. And last one, number 7. So same, you just want to start out by subtracting 1 from each side. So you're going to get negative 16 equals negative 2, absolute value, x plus 6. Next step, you want to divide both sides by negative 2. So you're going to get 8 equals x plus 6. And the last thing, you want to isolate this and break it up into two parts, because x plus 6 could be positive 8 and x plus 6 could also be negative 8. So I'm going to solve for x. So x equals negative 14 if I subtract 6 from each side, or x equals 2. When you're solving absolute value word problems, what I want to do is, there's always some type of tolerance, like give or take, or within, or the error. So that number is always by itself. So this question is, you have money in your wallet, but you don't know the exact amount. When a friend asks you, you say you have $50, give or take 15. So this give or take 15 is the tolerance. So I'm going to put 15 by itself. Use an absolute value equation to find the least and greatest amount. So you could have in your pocket x minus 50. So the amount of money that you have in your pocket subtracting 50 is the absolute value that's going to be 15. So if you have 75 minus 50, the absolute value of that is 15. 75, or not 75, but 65. If you have 35 minus 15, you're going to get minus 50, you're going to get negative 15, which is still in here. So if I solve this, I'll have x minus 50 equals 15, and x minus 50 equals negative 15. So if I solve for x, I have x could be $65, or x could be $35. So that's the least and the greatest amount that I have in my wallet. Okay, number 9. So they're all kind of set up similarly. The ideal diameter of a piece of metal rod is 2.5 inches with an allowable error of 0.05 inches. What's the maximum and minimum diameter of the metal rod? So my tolerance is 0.05. And I'm going to do x minus 2.5 because 2.5 is the one that I want. So I can write two equations for this. I can write x minus 2.5 equals 0.05, and x minus 2.5 equals negative 0.05. So x could be 2.55 inches, and if I add 2.5 right here, x could be 2.45 inches. Number 10, a machine fills Quaker oatmeal containers with 32 ounces of oatmeal. After the containers are filled, another machine weighs them. The container's weight differs from the desired, or if, I should say if, the container's weight differs from the desired 32-ounce weight by more than 0.5 ounces, the container is rejected. Write and solve an equation that we can use to find the heaviest and lightest acceptable weights. So we have our tolerance 0.5 ounces. So it's going to be x minus 32 equals 0.5. So I'm going to do x minus 32 equals positive 0.5, and x minus 32 equals negative 0.5. So when I solve for x, x could be 32.5 ounces or 31.5 ounces. And then the last one, a machine is used to fill each of several bags with 16 ounces of sugar. After the bags are filled, another machine weighs the bag If the bag weighs 0.3 ounces more or less than desired weight, it is rejected. Write and solve an equation to find the heaviest and lightest bag. So my tolerance is 0.3, but I need to be 0.3 ounces of 16. So I'm going to do x minus 16 equals positive 0.3, and x minus 16 equals negative 0.3. So when I solve, I get x equals 16.3 ounces or 15.7 ounces.